Right, moving along now with the same customer as whatever we did yesterday. I'm also doing this AAA battery comparison video. Unfortunately, this Fidelity 2000 has been got at, according to the label. He thinks it's been turned into an 80 channel set, and I've said this a million times. Not only is that illegal, but they never work properly. I've never seen one that work properly. And thirdly, they end up killing the radio. That's been my experience. So, how to turn a really good radio into scrap, and that seems to be it. So I don't know who goes around doing this, but it seems to be a waste of everybody's time and money. So, we'll open up the set, see what remaining screws it's got. It's going to have all the 4 lids off. It's got the wrong kind of screws. These are self-tappers and they shouldn't be, which isn't helpful. So that's the speaker lid off. Oh no. Oh, I don't know what that is. Oh dear. Well, it's certainly been got at, hasn't it? Oh. T.C. George, 26 January 94. Is that Top Cat, like the TV show? So what we'd better do, because I've found my experience has been that we've only been able to recover about 75% of radios that have been messed up like this, which is a shame. So the best thing to do with it being a customer's is to test it and see whether it works at all. Because what I don't want to do is the customer say, "Oh yeah, it was perfect apart from that," because it could always happen. Probably one of the reasons we don't normally do end users. Where on earth is the Cybernet power lead? We'll power it up off the crocodile clips. So there's a relay in there. Gets even more bizarre. Now we did have a mic on here suitable for Cybernet. Did I leave it on the Amstrad? Oh well, I'll use the customer's Amstrad mic, it's wired the same. Okay. Oh, so it's got a Roger bleep, has it? Well, that's going to have to come out as well. Right. So I'll switch the picture-in-picture on. Let's see what power it's doing. And it is doing, so Fidelity 2001, and it's doing 2.5 watts. The deviation, wallow. Wallow. 1 2 1 2 1 2 wallow 1 2. I've got nothing. Just check the mic gains up. Just check with a monitor receiver. 1 2 1 2 wallow. No, there's no transmitted audio. There's a bleep coming from inside the set, but it's not transmitting it. So that's broken anyway, isn't it? So no TX audio. And let's look at what the frequency is doing. Should be 27.79125. 27.790. It's actually in spec, but I'd like it nearer than that. Now, is this one where you press the channel 9 switch and it turns into something else? Or is it channel 9? Ah. No, it's channel 9. Is it one where you press the PA switch and it turns into something else? No, you can't do that on these, can you? Oh! You press the dimmer and it turns into something else. And that's miles off frequency the other way. And it's always a compromise, what I've always said. So it's minus on UK and it's plus on CPT, and I say it's illegal to do that anyway, so it's got to come out. So we will look at received audio. And we'll look at the synod meter and just see what it's doing. So RX synod, I'll tell you what, we'll do all three. And at the moment we've got 0.57, which actually is not that bad. 12 decibels, 0.42. For 20 decibels, if it achieves it, the radio can't do 20 decibels. So for 18 decibels, no, I'm getting there. It's there. It is 2.4 microvolts. So hopefully we can bring that up if we get rid of all this junk. Alright, so we're going to have to spend some unhappy time doing that. I don't know what my bin men think. Right, we'll pause the video and get rid of some of this junk. Okay, so the good news is it seems to work. And we've rewired the microphone without that dodgy, dreadfully made Roger Bleep board, which has not had the flux removed, and oh dear, not good. More for the vertical filing cabinet. I would guess that we now have transmitted audio, having removed that. Let's just see. 1, 2. Let's just put the monitor receiver on. 1, 2, 1, 2. Testing 1, 2. No, we don't have transmitted audio. So I wonder what's happened. Right, first of all then we'll do the VCO. So we need to select channel 40. And looking at my notes for the Rotel 240, It is receive. I don't know whether that... I don't think that should be there. I'll just turn the radio off. No, that capacitor shouldn't be there. They've had to mess the VCO up, haven't they, to try and get those extra channels to fit. And that can be thrown away as well. Okay, what we were trying to do was to put the test prod. Have we got no crocodile clips again? Alright, we'll pinch that one off something else. Yeah, we need the test prod onto chassis. Yes, we can see that. Resistor 4 far end. Switch the radio on. Channel 40, and what did I say? 3.5 volts? 4 volts. Going to transmit and select, get the variable capacitor there to 4 volts. .93 will do me. Now we'll go back to receive. 4.04 is fair enough. 3.95. Right, let's go to channel 1. And we need to have between 1.8 and 2.5. That's receive. That's transmit. So the VCO is now reset. Thank goodness for that. At least I'll have 40 real channels. Before we go any further, I'll just do the frequency. .601. Look at that, it's gone straight back. Absolutely as it should be. So just go to channel 20. 2779127. Absolutely spot on, and of course it would be the variable capacitor just there if it had needed altering. It's not often that happens. Right, so we'll go back to the meter, and we now need to do the tune-up on this. I've lost the trimming tool already. So let's see what we can do. Well, we've now got a little bit more power. It's now doing 3.8 watts. So that was the first. We've now gone to the second range on this meter. So we've peaked that. I'll put the spectrum analyzer on ready with this having been messed about. So a good 3 watts there. 3.1 there. Let's go back and check. It's about where we want to be. And then with the green tool, that's the one I won't be able to find. Peak all 3. Wow, that was out. So we're now about 3.8. We've got a broken core on the next one. I can't let that go. Right, we'll have to unsolder that. Doesn't want to come out. And this could be broken all the way through. It's always nice if we can turn it round and just like an old cottage step. I tell you what, it is only broken at the top. That looks like it's going to go in all right. So we'll solder it back in place. Right, with it turned round the other way, let's see what peak we can get. We were about 4.1. These are all at the bottom. I don't get this. Right, let's see whether it is on the spectrum analyzer because of what's happened with it. We'll select that. We've just about got 3.94 watts. And before I tune that properly, we'll just make sure we've not got a terrible mess on here. Right, frequency 27.79125 megs. There we are with its fundamental. You know what, there's nothing at 50 odd. Okay, we'll tune this properly then. So just to recap, we need to knock L9 anti-clockwise. Just go back to the power meter. And now let's see what we've got balance wise. 40, 3.9 watts, 1, 4.1. So see if we can do a better job of that. So now put that one clockwise slightly. So channel 1, 4.1, channel 40, 3.7. It's still not quite balanced. Right, we'll start again. Maximum, we know that's maximum, but we'll just check. Maximum. So we want to put that clockwise to maximum, anti-clockwise to 4. Check again. .9, 4.1. Okay, so this one isn't going to quite balance. However, on the spectrum analyzer, we'll go back to that. We've got nothing. 54 megs is here. Got nothing. We'll turn that off as well. So let's look at the RF power meter. Go back down to channel 20. Now I've got, oh my goodness, it shoots across. I can't get it less than that. Right, low power should be 0.4 of a watt. And low power is full power. In fact, low power is always high power. Oh, it's tone high and low. That's why I'm getting that. Let's do this. Well, these are often dirty. Make sure that switch is not dirty. So we've got about 400 milliwatts there, and then back to full power. Right, we need to get to the bottom of why this deviation is wrong. So we'll start by making sure the deviation control is cleaned. Make sure that mic gain's at full, which it is. Wallow. 1, 2. Let's put this monitor receiver on. Testing 1, 2, 1, 2. Wallow 1, 2. Wonder what's happened here. One thing we can do is just touch the deviation control with it on transmit. Nice simple little test, especially if we had a metal screwdriver. See whether it's working on public address. And the answer is no. Very quiet on public address. I think the best thing here to do is to go back on that later on. So we've done the transmit except for transmitter audio. So I think we'll move on to receive, just so we know where we are with the radio. So we know it's receiving, we already tested that. Okay, so rejoining the set the next day, I think what's happened here, I think somehow 12 volt has ended up down the mic line. If you remember, we got no audio and we got low audio on receive. It's certainly enough to do with the readings we needed to take initially, but there wasn't the several watts of output that you needed. And what I discovered, first of all, is that the varicap diode was blown up, and its resistor at the side there, 39k, also blown up. Out of precaution, I changed a capacitor there, and we changed the double op amp there, which is used as a speech processor, and I started to get audio, but really low volume. So we then went further down this way, checked a couple of transistors like the preamp one, and that was fine. I even changed the audio IC by substitution, and we actually borrowed a part out of one of our working sets, and we'll put this part in our working set. No problem there. And then just going through the circuit diagram methodically, and a couple of capacitors later we changed the 100 microfarad capacitor just there, and my light's in the way of the picture. So let's see where that is on the circuit diagram. Capacitor 94. It's there, yeah. So what was happening, if I just zoom in on that, make sure we're in the right camera, and make sure I can see where my finger is on the monitor. So the microphone comes in here, and capacitor 98 is an electrolytic capacitor right on the microphone input. So that's after the mic gain control and after the treble cut switch on the Rotel 240, which this is the circuit for. So we changed that out of precaution, and it read fine. Changed the preamp transistor here, and that was no different there. And so eventually we've got capacitor 94. So as the audio comes out of there, that would indeed drag it down to deck. which is what's happened. So meanwhile, though, at the other end, we've had to change this IC because one op-amp section was also destroyed. One was working, one wasn't, but because you can't cut the chip in half, so that sorted that out. We changed the RV2 as a precaution, and then we've had the varicap diode was destroyed, and the resistor 8039K. If we're just up there. There we go. There's the varicap diode, diode 13, and resistor 8039K. As a precaution, we changed 140 there, which is 3.3 microfarads at 10 volts, upping that to 16. Now, all the capacitors which we've changed are 10 volt rated. Normally, they'll only have 4 volts on them, so that's fine. We've put 16s on, and what's happened is somehow that circuit's either gone wrong, or it's been fitted wrong, or it's been messed with, and it's put 12 volts on the mic line, so we've got damage at this end, and then for some reason we've got damage at that end, so it probably found a short path through when it destroyed the IC. So that's what's happened there. I remember having an Amstrad 900 in, and they didn't want to claim under warranty at the time, because they'd put a 13 amp mains plug on the mains, on the power lead, and connected it up to mains. I certainly wasn't recovering that for them. So I've just done that behind the scenes. I've not turned the background music down, so if you hear an orchestra in the background, normally we turn the tannoy system down here. So, Wallow. We've got Wallow. I can just pop that up a fraction, and we'll just use our little, and that sounds fine on our monitor receiver, which I'll now put away. So just switch this little oscillator on. So just pop that up a fraction. Wallow. That's it. There we have it. So I think we're there. We'll just check power again. Still got about 3.9 watts. Good. Now, because I've sorted out the receiver at the same time, because the lack of audio was the same fault, and we know the receiver is actually receiving, we'll just dial 79125 into the signal generator, and I think we've spent 5 40-minute sessions on this set. Luckily, the customer brought some scrap sets, so we'll be able to give a £2 credit for each one of those he brought in. It'll help. Right, so we've got 27,79125, so we'll go over to the oscilloscope. We'll put an S9 equivalent signal in of 100 microvolts, and we'll just now look at that on the oscilloscope and see whether we can peak that further than where it is. You know what? It was already spot on, so that hadn't been fiddled with. Now it's already receiving a good sensitivity, and we'll go over to the synod meter. Camera 4. I'll remember which ones they are eventually. So we want to set the levels so that we've got about 4 decibels on the cyanide meter. We'll start with the coil there. So we only managed to recover about 75% of sets which have been 80 channeled, and I've never seen one that's worked properly that's come in here, because I always test them before we delve in, because I don't want the customers to say you broke it when it's pre-broken. You know, the receiver's virtually spot on. Looks like Mr. Screwdriver didn't mess with that. What I want to do is to be able to get 20 dB cyanide, because we didn't get that, if you remember, when we did the initial test. Let's just see what we're getting at 12 now. 0.41. See whether we can just get a little fraction more. It's better than spec says anyway. I think we're about there. So we'll set the S meter. I'll put the signal generator back to S9. And the S meter adjustment is there. I think that tool was a bit large for that. That's a dirty control. And there we have S9, which we can turn down and turn up with the signal generator. So that just needs to do the squelch. We haven't restored the dim bright function yet. I need to get a resistor in there. Okay, so let's look at the squelch. Turn the cyanide meter off. We'll turn the oscilloscope off. We'll set the signal generator to 100 microvolts, and we'll turn the squelch up to full. And I want that to be squelched out at 30, which it is. It comes in at 100, it goes at 30. It's exactly how it should be. There's another thing which hasn't had to be adjusted, and that the preset is just hiding under that wiring harness there, but we don't need to touch it. So we'll just check the sensitivity at the bottom end. So now I've turned the squelch to minimum, we've switched the signal generator off, we've parked it at 0.3 of a microvolt, and now we're going to switch the squelch to threshold position, or turn it rather. Now we switch the signal generator on, and then we see where that squelch position is. So it's coming in about 0.65 of a microvolt, and it's leaving at 0.51. So we'll just see whether that's anywhere near what specification says for the Rotel 240, which is the same set. What does it say? Receive sensitivity. I've never seen that before. Voltage 10.8 to 15.6 never exceed. So although it's 13.2 nominal, the kill factor is 15.6. Less than 1 microvolt for 20 dB. So less than 1 microvolt for 20 dB. Squelch sensitivity is supposed to be 1 microvolts to 10 microvolts, and we've got squelch now from 0.54 to 30 something microvolts, so much wider range and specification. So we'll write these figures down. So we've now got, we can safely say we've got 3.9 watts, because it's slightly higher at the edges on this radio. TX audio is now 2.2 kilohertz. So let's start with these receive figures. We'll go back to synod meter. I'll do these in reverse. So for 10, still 0.42 microvolts. For 12, it's now 0.49 microvolts. And for 20, which we couldn't get before, you see, we could only get 18. Well, now I've got 1 point something through that, so let's have a look. 20 is now 3, 2, 1. Just change scales again. Yeah, we're just on the edge of the scale there. It's 0.9 microvolts. So it's the IF which was slightly out, rather than the sensitivity being slightly out. So we've brought that down dramatically, so you'll get much better signal to noise ratio, even though at the bottom end it's no more sensitive. Of course, the radio is now on frequency as well. And I'll just do a final check on that. 79125, there we are. We're done. So all it remains for me to do is to go over the printed circuit board with Mr. Chippy's toothbrush turn the power supply off. I'd love to know why people do these modifications. Pointless, and making the set illegal as well. Perhaps there's something about doing things which are illegal, you know, like driving down the road at 100 in a 30. Not having a driving license, you know. Not having a radio license. So apart from a lot of time, it's been about £5 in parts. It's not been too scary because the parts it's used aren't expensive. Now what we haven't got when I looked was we haven't got, it's a bigger speaker than I was expecting. We haven't got any case screws, and so I wasn't able to screw the Amstrad together. I think this is the other way around. So I won't be able to screw this together until some replacement screws arrive through the post. As I said, we have these things, and I buy them 1,000 at a time normally, so I know they're in a storage thing somewhere. We're having building work done probably for the next year, so that's how it's going to be. So what, they'd been modded, yes. Yeah. So the Roger bleep's the killer. On this occasion, the illegal 80 channel modification wasn't the killer, but it was the Roger bleep. I don't even know what the relay was for. Anyway, we'll put a couple of screws in this because it did have a couple of screws it came with. 1919 Roger. Oh, someone's on his left-hand side. Well, there we go, and that's on its own speaker, and that's with our microphone. I don't think this one came with a mic. So that's our very broken set for the week. So hopefully some screws will turn up on Monday. I just bought some, you know, kind of local mail order instead of buying them in the usual quantity we do. So we'll sort that out. We'll sort the Amstrad out. The next set from this customer is a intermittent Murphy base station. The trouble is we've now spent a lot too much time on this customer's stuff, so I might have to move on to another customer. So we'll see. We'll see. Right. So it lives to work again. We'll do an on-the-air test later on with Mr. Chippy. And this is the Fidelity CB2000, now unmodified, unmessed and unblown up. And thank you for watching.